In this video, I'm going to be doing 3 examples of determining the present value of a continuous money flow. So our basic formula for present value is the integral from A to B of our revenue stream times e to the negative RT. That's the general formula. The challenge is usually to determine the revenue stream. That's where most of the work is. R is usually given to us, as it is in this first example. R is 7.45. So what is the revenue stream? Well, there are 3 types of revenue streams, as I mentioned in a video that I did on future value. In this particular example, we have a constant revenue stream, the annual income stream of $40,000. In other words, every year it's going to be $40,000. It is not changing. It's not increasing. It's not decreasing in any way, shape, or form. Every year is another $40,000 continuously. And we also know that the time is 8 years. And once again, we know that the interest rate is 7.45. So setting up the integral for this, we would have the integral from 0 to 8 years, 0 meaning right now, to 8 years in the future. Our revenue stream is simply the $40,000 times e to the negative 0.0745 t dt. So that is our integral. Now all we need to do is integrate that. So when we are integrating these, we're using the U substitution rule for an exponential. What it comes down to is you're going to take this number here, you're going to divide it by the interest rate, negative 0.0745 times e to the negative 0.0745 and evaluate that from 0 to 8. So this is your antiderivative. This is your f of x that you would put into Desmos, and then you would evaluate it from 8 to 0. And we've done that a number of times, so I will leave that up to you. In the next example, once again, we are looking for present value, but in this particular case, we have a revenue flow that is not constant. So let's see what we've got here. Garrett was injured, no longer work. The result of a lawsuit, he is to be awarded the present value of the income he would receive over the next 23 years. So we have our upper bounds of integration. His income at the time was $52,000. However, it's expected to increase annually by 4.25%. So this revenue stream is constantly changing. And so this type of a revenue stream, you're going to start with the current salary of $52,000. And because it's increasing annually by a percentage, is a percentage increase, we're simply going to take and multiply that by e to the 0.0425 t. So this is how we deal with a percentage increase. All right. So then our integral for present value is going to be the integral from 0 to 23 of our revenue or income stream. I use revenue and income interchangeably. As I explained in another video, it means the same thing. Now, this is simply the revenue, remember. This is the revenue. We now need to multiply that by e to the 0.0825 with a negative out in front, t, dt. So we have 2 exponentials here. We have 2 exponentials. So all we need to do is combine them by adding the exponents. We're going to add 0.0425 and negative 0.0825. And so we will have our integral from 0 to 23, 52,000E. So a negative 0.80825 and a positive 4.25 looks like it would be a negative 0.04 dt. All right, and so now we are ready to integrate. And so just like in the last problem, our present value, we're going to have the 52,000, divide that by the exponent, negative 0.04, times e to the negative 0.04t, evaluated from 0 to 23. And once again, you can just do that in Desmos. So that's how you handle a problem where the revenue or income is increasing, and it's increasing by a percentage. In the third example, we have a situation where revenue is also increasing, but not by a percentage. So take a moment and read the problem. So it says that the income generated by the machine will be a constant $11,000 the first year, and will increase by $1,000 every year after that. So the revenue is going to start off at 11,000, but it's going to increase by a constant amount. Every year it increases by $1,000. So what we're going to do is simply add to that $1,000 the amount of the increase times t. And so what we have is we have a linear revenue function. And then the rest of it is pretty much the same sort of thing. We have 6 years and the rate is 4.55. So our integral for present value will be from 0 to 6. And our revenue stream will be 11,000 plus 1,000 t times our e to the negative 0.0455 t dt. Now the hardest part about this problem then is actually doing the integrating, because this requires integration by parts, which is one of the reasons why we took the time to learn it. Because a lot of problems in applications do have integration by parts. We have two different functions of t, this linear function and the exponential function. So what we want to do is we want to have d is always going to be the algebraic one. And remember what we do, we just take the derivative of that until we can't do it anymore. And we put a negative out here. And then we have our I. And that's e to the negative 0.0455. And we take antiderivatives of that. So what we're going to do is we're going to have negative 0.0455 divided by negative 0.0455. And then for the last one, we're going to do it again, e to the negative 0.0455 divided by negative 0.0455. But we have two of them now, so square it. And so those are the derivatives and the antiderivatives. And so now we're going to take this times this and all of this times this. So what's that going to look like? Well, we'll have 11. So our present value is going to be equal to 11,000 plus 1,000 t times e to the negative 0.0455, and all of that is divided by the negative 0.0455 minus 1,000 e to the negative 0.0455 divided by the negative 0.0455 squared, which will then become positive. So this was the yellow part, and then this is the blue part of what I had here. Now, my recommendation is you just pop that all into Desmos, and then we're going to be evaluating that what was it, from 0 to 6. Be careful when you put all that into Desmos. This will be your, this whole thing is your antiderivative. And then you're just going to do f of 6 minus f of 0. So the emphasis on this video is how to set up these problems. The integration is actually, in most cases, pretty simple. And then you just evaluate the antiderivative using Desmos.